In this video we're going to look at slope. So we're just going to correct some of the questions that you had for homework throughout the previous week, and maybe some extra ones in there too. Okay, so the first two questions look at positive and negative slopes. So telling us if a line is increasing or decreasing. What's really important with these questions is that you always look at the line from left to right. Okay, so if we look at this at line A, okay, if we start from the left and look over to the right, as you can see the line is actually increasing, so this is a positive slope. Okay, the same goes for this one. So if we start left and look right, the line is increasing. Okay, think of it as, I always like to think, if you drew a little stick figure here, is this person walking up or are they walking in a downward direction? Okay, and as you can see they are walking up. Okay, so the steepness of a slope, or how steep a line is. Okay, example number, or question C here, if we look from left to right here, the line is actually decreasing, so this is a negative slope. Okay, part D, again this is positive, because from left to right the line is increasing. This one is quite a steep line, but if we put a little person here, they would be actually walking down the slope. Okay, so this is actually a negative slope. And this last one here, again, if we draw a little person here, they're walking in a negative direction or downward direction. So this is a negative slope. Okay, as we can see here, we're just asked to point out which lines are positive and which lines have negative slopes. Okay, so as you can see here, B and C are all increasing from left to right. So B and C have positive slopes, and A and D have negative slopes, because A and D, they're going in a downward direction from left to right. Okay, the next questions here, question 3 and question 4 and question 5, we're just asked to use the rise over run technique to find the exact slope. So far we've just been stating if the lines had a positive or a negative slope. Here we're actually going to put a number on it. Okay, generally the bigger the number, the steeper the slope. Okay, and the smaller the number, generally if it's a fraction, it's not a steep line. Okay, so we'll take a look at question 3 here. When we're using the rise over run technique, we pick 2 points on the line here. So we're going to pick the start and the end, and we're just going to draw a little right angle triangle here roughly. So as you can see, the line rises by 2, so rise over run. Okay, so it rises by 2, and the run is, the horizontal distance here is actually 3 units. So the slope of this line is 2 over 3. Okay, as you can see, this is a much steeper line. Okay, so it should be a bigger slope than the previous one. Okay, so we're going to pick 2 points here. I'm going to draw a little right angle triangle. Okay, and using our rise over run technique, the rise here, as you can see, is 3 and the run is 2. Okay, so the run, the horizontal distance, and the vertical distance is 3. Okay, and as you can see, 3 over 2 is in fact bigger than 2 over 3. Okay, in part 3 again we're going to mark 2 points on the line, and we're going to measure the rise and the run, and we'll write it as a fraction. Okay, so the rise here in this case, it goes up by 4, and the run is 2. This can actually be simplified because 4 divided by 2 is 2. So this is a steeper line than the previous 2 that we've looked at. Okay, this one's a little bit more difficult because, well, the points are marked out, but it's just a straight line rather than it's sort of a zigzag line. But we're going to repeat the same step. Okay, we're going to draw a right angle triangle where they've drawn their little points. Okay, rise over run. So as we can see in this example, the line rises for every 3 it rises, it runs for 1. Okay, so the slope of this line is actually 3. Okay, same with this one. This is drawing a little right angle triangle on 2 points. We can see it rises, so rise over run. The rise is actually 2 and the run is 1. So for every 2 and we can actually continue this. This can be done anywhere on the line. Okay, so for every two boxes it rises, it runs for 1. Okay, so the slope of that line is 2. So you don't necessarily have to use the points that are given. You can pick whichever one you prefer. Okay, in this one, this is a nice small one here, but we're going to start off with their points, their rise and their run. Okay, so they've picked these 2 points for us. As you can see, for every rise, for every 1 unit it rises, it runs for 1 as well. Okay, so the rise over run is 1 over 1, which is 1. So the slope of this line is 1. Now, just to show that that actually works anywhere on the diagram, so I'm going to pick this point and even this point. Okay, and again, once I've drawn my points, I'm going to draw my little right angle triangle. And as you can see, it rises for 5. And it also runs for 5 as well. Okay, but hold on a second, 5 goes into 5 once. So it simplifies and the slope is the same. Okay, in example number 5 here, why is the slope of this line negative? And use the grid to work out the slope. Okay, it's negative because it decreases from left to right. So we're reading from left to right. And we're going to use the grid to find the slope. Okay, so what I'm going to do is just pick 2 points on the line. And I'm going to draw my right angle triangle. And then I'm going to predict my rise over run. Okay, so my rise here is 3. And my run is 2. So my slope there is 3 over 2, but it's actually minus 3 over 2 because this line is negative.